Hello, this is Dr. Moore, and this video will concern geographic influences on climate. Until this point in our unit on climate, we've been looking at broad global patterns, like how the increasing solar radiation at the equator causes the Earth to be warmest there. We've looked at atmospheric circulation patterns and how that explains the distribution of biomes on the planet. Today, we're going to reel it in and we're going to look at how local geography can influence climate. And we're going to pay particular attention to two variables. Those are mountains and proximity to water. Before we look at the specific ways that these geographic features influence climate, let's remind ourselves of a couple of key science principles. The first one is that air cools as it rises. The second one is that cold air can hold less moisture than warm air. And the third one is that water changes temperature more slowly than air does. You can see this when you go to the beach. When you go to the beach, the sand is crazy hot and the air is hot, but the water is much cooler than either because it takes a very long time, a lot of energy for water to change its temperature. But when you go to the beach in the wintertime, the sand will be freezing and the air will be freezing, but the water will still be relatively warm, at least warmer than freezing. And that's because it takes water a long time to change its temperature the other way. It takes a long time. It has to give off a lot of energy for its temperature to decrease. So we'll start with mountains. The first effect of mountains on climate is pretty well known, and that is that the higher you go in the mountain, the cooler the temperatures get. And the Grand Canyon is one of my favorite places to demonstrate this. The rim of the Grand Canyon is about 7,000 feet above sea level, so it's higher than Denver. But then when you hike down to the bottom of the Grand Canyon, down to the Colorado River, you've hiked down almost a mile in vertical elevation. And so the temperature, the climate at the rim versus the bottom of the canyon is completely different. So I've hiked the Grand Canyon in December when it's been 65 degrees down here by the Colorado River and really, really pleasant. And then I hike up in my shorts and a t-shirt and I emerge in a snowstorm at the top of the canyon. This effect of altitude on temperature also creates something called a rain shadow. The rain shadow describes the fact that the windward side of a mountain range will get more rain, and the leadward side of a mountain range is often drier. Now, before we explain how that happens, let's just make sure windward means the side of the mountain that faces the wind, and leeward means the side of the mountain that doesn't face the wind. Now, the reason rain shadows occur is prevailing winds pass over a body of water, and as they do, evaporation causes the air mass to pick up moisture. As the air is forced over the mountain, it cools because as air moves higher in the atmosphere, it cools. Cool air can hold less moisture than warm air, so the water starts falling out of the air as precipitation. And then, as the air crosses over the peak of the mountain and descends, the air is dry. It's lost all of its water when it went up the mountain on the other side. You can see a rain shadow very clearly in the state of Washington. So in this map, you can see that the rainy side of the state is on the western side. This is where the westerly winds, so Seattle is between 30 and 60 degrees north. That means it gets winds from the west coming over the Pacific Ocean. As those winds climb the Cascade Mountain range, the air cools, it loses its ability to hold the moisture that it picked up over the Pacific. It precipitates, and then it crosses over the mountain much, much drier, which is why we have a desert on the eastern side of Washington state. You can see the same pattern really dramatically if you look at a satellite photo of Hawaii. Now, Hawaii exists between 0 degrees and 30 degrees north, so its prevailing winds are coming from the northeast. You can see those northeastern winds pick up water over the Pacific Ocean as they come into Hawaii and start to climb this mountain range. The air rises, it cools, it drops its moisture, and then the southwestern side of Hawaii is much less green because there's much less precipitation on that side of the island because the air mass lost all of its moisture as it climbed over the mountains coming from the northeast, moving to the southwest. The second geographic influence on climate we will consider is proximity to water. Water moderates temperature. So, locations that are closer to water will have less extremes in their temperatures than places that are very far from water. You can see this in the climatograms of Los Angeles, Oklahoma City, and Myrtle Beach. Oklahoma City, of course, is in the center of the continent. It's not very close to water. And as you can see, it has the greatest range in temperatures. It both has lower lows and higher highs than either Myrtle Beach or Los Angeles. You can also see that this effect is stronger in Los Angeles than Myrtle Beach, and that's because in the United States, our prevailing winds are coming from the west. And so the winds from Los Angeles are coming directly over the Pacific Ocean, whereas in Myrtle Beach, the winds is coming from the rest of the continent. So the effect, the moderating effect of the water, the Atlantic Ocean, is less pronounced in Myrtle Beach than it is in Los Angeles because the water is or the air is coming from over the water in LA, whereas it is not in Myrtle Beach. Proximity to water also affects lake effect snow. So, lake effect snow refers to the fact that locations on the leeward side of a lake receive much more snow than other locations. And you can see this in this image showing the snow belts of the Great Lakes. So, the winds are coming from the west, moving to the east in this part of the world. And the snowy parts of these lakes is always on the eastern side. And the reason that this happens is as the cold air passes over the lake is relatively warm because it takes a longer time for water to change its temperature. As a result, the lake warms the air slightly and makes it more able to hold moisture. So water evaporates into the air, which is warming as it crosses over the lake. And then this air moves from the lake onto land. It becomes a lot colder as it does this, and so it's less able to hold the moisture that it picked up, and so it dumps all of that moisture in feet and feet and feet of snow in places like Rochester and Erie, Pennsylvania. So at this point, I hope you can explain how mountains and proximity to water affect climate. You should be able to use the terms rain shadow, windward, leeward, and lake effect snow.